Good day. This is Mr. Whitlinger. I'm going to teach through Metamorphic Rocks just so that you can have a different perspective of Metamorphic Rocks as you go through the presentation. So I'll try and add value to your process and stories if I can. The general process of teaching through rocks is you start with igneous rocks and then you go into breaking them into sediments, and then sediments go through the process of lithification, which means they get glued together, compacted, cemented, and hardened into another rock. And then you can add a little bit of heat or pressure, or heat and pressure, and you'll start to change the form. So meta means to change, morphe is form. So you have completely changed the form of a rock, and it is either an igneous rock or a sedimentary rock. And so that's why we kind of present those first and then we change them. So I would argue metamorphic is one of the easier of the three to wrap your head around. There's two main concepts and they're very obvious. And so let's get started. So here we go. We've got sediments, metamorphic, and igneous rocks just as a definition. Cool. Igneous means from the fire. Metamorphism is a process. So to change the process of a rock, you can squeeze it to the point where you realign the grains inside of sedimentary rocks, or realign the way the minerals are arranged inside of the igneous rock. And oftentimes you will literally see the compaction of or the direction of the forces, which is really, really great. So if you're looking for what are the connections inside of metamorphism, they show you, they're an indicator of which direction the pressure came from. So very, very cool. So rock cycle is more than just a one circle, because a metamorphic rock can then be weathered and eroded back into sediments, and you could just be in that sedimentary right at the surface, just changing form constantly within the systems, or you could be exposed to a magma chamber and you completely melt, and you could actually change form before you melt and go into that magma chamber. So what often happens is magma will come under the ground or be recycled through subduction. So one plate going underneath another plate. And then that magma comes up and it's got a lot of heat, and it will reignite the growth of the minerals inside of the rocks that are surrounding the magma chamber. Very cool. All right, so let's see if I think I've covered pretty much everything. So pressure and temperature, they increase with depth. That should make sense. I used to play this game with my brothers. I don't know if you've ever done this, like where you dogpile. And a dogpile is basically one person gets on the bottom and then everybody just like jumps on top of you. And then you have like layers and layers of children. And then usually the heaviest person on your street gets on top and just about kills everybody. And then as you pull those people off, like you can breathe again, and often that happens with rocks. Well, they'll like fragment and break because the pressure is now gone after they solidify. That's a sedimentary thing. But metamorphic rocks, at the deeper you go, the hotter it can get. And so think of metamorphosis, cool, changing from a caterpillar to a butterfly. That's really great. So here's one of my favorites. Something that is granite, right, which is Patrick. For those of you who are watching this, Patrick is my teaching assistant. He's someone you can't take for granted, and he's definitely not nice. So if I were to compress my piece of granite, he would become a piece of gneiss, which is a metamorphosed granite, and literally all that would happen is you would start to have these bands form from the pressure, which is cool. That's his morphe. All right. There's contact metamorphism and regional metamorphism, and I will let you watch that video on your own time. I'm just going to kind of blitz through this as quickly as possible if I could.
All right. In this video,
keep going. It could be small scale, it could be large scale. So, for example, you've got a magma chamber down here. Let's see if I can. There's the magma chamber, and then where this is touching, you could imagine it's very hot, and that heat is radiating out and causing change in the surrounding rocks. So here we've got shale, we've got sandstone turns to quartzite, limestone turns to marble, and marble is very, very beautiful. We use it in a lot of decorations. It's very easy to carve. It's consistent, which is what Michelangelo, when I went to the Vatican, they would use marble because as they were, you could make really small, fine adjustments and make rock look very smooth because it's very consistent, which is cool. So here we've got our limestone, and then underneath that right there's your igneous rock, magma chamber, and then here would be your contact metamorphism. Oh, sorry, right here, the white. So the limestone changed to marble right next to it. So this right here is called a dike or a sill, depending on the angle. Basically, it's an intrusion. So lava has just burned its way through and just consumed everything, which is cool. I would argue that this is probably high in silicates. And then this dark rock right here, from this distance, I would argue it's dark, it's a little more mafic. And so stark contrast between those white bands and the dark bands. Regional metamorphism, this is where the entire region has undergone pressure. And so this is really indicative of continent to continent convergence. And so very, very helpful when you're using this to talk about change within the system. So they expose large areas that would be the whole region. And what's really interesting about this is the banding. So this right here, here's a syncline. Right there, you can make an A, and so that's an anti-syncline. There's the bottom that you can make a U. You can dive into that, those definitions, which is great. Here's the big thing, the takeaway for today. You have got to understand the difference between foliated and non-foliated. And in some versions of geology, they use the word unfoliated. I'm the German version, and so we use the word non-foliated. So foliated literally means banded layers. That is it. And so what has happened in this situation is there has been pressure in this direction. I can't draw it fast enough. And the bands or the minerals have started to kind of segregate a little bit. The ones that are they've moved closer to each other and settled in. A cool concept to think about would be like the cohesion and adhesion of the situation, which is great. Non-foliated, this word non-foliated, there is no bands, period. This would be indication of heat without pressure. Perfect. So pressure would be the foliated, heat would be the non-foliated. I would argue with the foliated, you're going to have heat with your pressure because that's what happens. I gave you a story about being dogpiled upon. And then just heat, that would be non-foliated. Perfect. So foliated metamorphic rocks, banding under pressure. Cool. Let's look at some changes. Non-foliated, no bands, very uniform in color, very, very attractive for artisans. We love to make countertops out of this. It's a soft, consistent texture, which is very, very helpful. Okay, if you're like trying to manipulate things into shapes. So non-foliated metamorphism, they do not have bands aligned. Quartzite would be all of the grains in sand, and then all of those sand grains start growing again. And so it looks like sand, but then bigger. And so very, very cool. Marble forms from limestone. You got to get that one. Foliated metamorphic rocks. You have shale and slate. All right. So here's a cool concept. Shale Shale is a sedimentary rock, and then if I compress it a little bit further, it will make a tink if you flick it. So you'll see that shale will make a thud. It'll just boom, 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 and slate will literally sound like a cymbal from a drum, which is cool. Phyllite, gneiss is from granite. Schist comes from basalt. This word right here is called schist. So here we go. Sandstone. We could take a little bit of sandstone and add some heat, a little bit of pressure because it's buried, part of the lithification process. And then that will reignite those grains into quartzite. Perfect. And then we've got sedimentary limestone into marble. Now, here's what's also amazing. The fossils inside of the limestone, which is indication of like a shallow sea, those fossils will be destroyed. They don't often make it through that morphing process. And so that's one of the problems with metamorphic rocks and sedimentary rocks is we've got these awesome fossils. Like let's say we got these fossils right here, and we start to change the form of that rock. We're also going to change the form of the fossils inside, and we lose that information. And that is one of the most tragic parts of metamorphism is you lose it. It's a chemical change. It is a one-way direction. Metamorphose, change form. And just like the caterpillar, it can't go back from a butterfly. Igneous metamorphic rocks, this would be granite, turns to something nice. Patrick is not nice. Sediments into sedimentary rocks. So here we got shale, turns into slate, which turns into phyllite, which turns into schist. So like as you go down this direction, this would just be more heat and more pressure. So I've buried it, I've lithified the grains, and then I've buried it some more, and I've added heat, and I've changed the arrangement of the atoms, and I changed the arrangements of the atoms a little bit more, and they start to grow and rearrange into another mineral maybe, and that turns into phyllite, which if I add even more heat and pressure, it turns into this really great rock called schist, which is very fantastic. It's very sparkly, very classic metamorphism. And when you turn it on the rock on its side, you clearly can see the layers. So uses of metamorphic rocks, we love to put this on buildings. Okay, so that slate, which makes a tink, is flat pieces, and they make perfect roofing shingles. And my father-in-law had a farmhouse, and it had a slate roof, and sleeping in the rain under a slate roof is an experience I will never be able to replicate. I don't think it's one of the most beautiful things that you could do. It's like an orchestra of the roof as it rains, because every raindrop is a different size and hits a different thickness of shale, even though they're all relatively the same. But like when a big drop hits a little, and it makes a sound that's very unique, and definitely a lifetime bucket list thing to do. Is like, I'm going to sleep under a shale roof, a slate roof. They make great pavers, which is cool. I've got these in my backyard. In American history, this would be, I think that's, I don't actually know where that is, but when I went to the Lincoln Memorial, Lincoln was completely carved out of marble. And so this is Americans replicating a lot of the Roman architecture and some of the classic headstones, which are really cool. All right. Porphoblast. A porphoblast, this would be a large metamorphic rock within a finer rock. And so that would be a big chunk of garnet inside of a big piece of gneiss, which is cool. All right. Let me see if I can move this so I can see. All right. So occurs, you could pause here and you could practice. Let you hit the pause button. Occurs when it comes in contact with molten rock. That would be contact metamorphism. Rocks whose texture is composition without melting it Texture, mineralogy. That would be a metamorphic rock. Metamorphism resulting from high temperature and pressure that affects large regional metamorphism. Easy. Large crystals of new metamorphic rocks. I believe that would be porphyroblast. Occurs when very hot water reacts with rocks. Hydrothermal. I Easy. Characterized by wavy lands. The wavy bands, this would be a foliated rock for sure. And I can't read completely composed of mineral blocky crystals. Blocky crystals would be non-foliated. So metamorphism change is either going to be banded or non-banded. Cool. I think that's the end of the situation. I tried to go as quickly as possible so that you could work at your own speed. And hi, everybody who's checking in on me on YouTube. Thank you so much.